It's like, all right, I'm getting rid of all my debt. And look, now I got new debt. Yay.
Hey, Matt.
Hey, Mike.
Would you like to do a podcast?
I sure would.
Then let's do that. Hello, and welcome to Hacking the Grepson, a podcast where two career developers talk about developing their careers. No, I have to workshop that one.
I think we talk about developing.
Right, and maybe developing a career in programming, if that's what you're into, person who's listening. Today, though, specifically, I believe we're going to talk about tech debt or technical debt, also known, as I read the Wikipedia about it, as design debt or code debt, especially in the software development world. You may be familiar with other kinds of debt, like taking out a loan and having to pay it back. In one way, tech debt could be seen that way, but it could also be seen other ways. But Matt, let's start with you. What is your experience with tech debt, and tell us, what that means to you, so we can get our discussion going.
I'd say the bulk of my career has been dealing with tech debt.
Oh, geez.
In one way, shape, or form. And I think most developers, even if they don't realize it, that is true. It just happens that tech debt annoys me, so I spend a lot of time trying to make it go away. When I talk about technical debt, I sort of mean one of two things. One is legacy code that has already accrued some debt, and I'll go into a little bit more on that. But generally speaking, it's some non-optimal decisions were made at some point in time in writing that code. And so when you go to add something to that code, it's more difficult than perhaps you would like it to be, or maybe the code's difficult to read or whatever. That's the most common way I think people encounter technical debt, is dealing with other people's code, just in general. And since people rarely get to build something from the ground up in this industry, most people have had to deal with that kind of technical debt, which may or may not be bad depending on the company and the project. The other kind is really the one that you introduce yourself, right? Okay, I have to do this thing. I have to add this feature to this product. I have this amount of time to do it in, so I can do it right and have it late, or I can do it and have it on time. And the business is almost always going to push for get it done now and introduce some debt. And the reason that it has the name technical debt comes from that kind of decision, right? I'm taking on a debt, which is my code isn't as good as it could be, or it's not maintainable or whatever. And I have to pay that off later, much like interest on a credit card. And there's ways of paying it off that introduce more technical debt, maybe in another area that I've seen, which is like paying off a credit card with a credit card.
Yes.
But more often than not, technical debt, in my experience, when I've most dealt with it, is me trying to get rid of it. I recognize it's there. I see it. The way my brain works in particular, I don't like when things are not done correctly or efficiently. And so I actually have difficulty working on projects that have a lot of technical debt in them unless someone lets me go in and fix the debt. And the bulk of my work at my last job was running our architecture team, and I spent a lot of time finding ways of phasing out technical debt so that the products could actually evolve and grow as they needed to.
I mean, is there even a way to do a project without creating some debt? Is there a debt-free coding strategy that actually exists?
So not an efficient one.
Not
if
one
you
that
know,
any business will sign off on?
Yeah. If you're following like a waterfall method, right, where you get all your requirements up front, you do all your design up front, you can design and build a system free from debt. The moment any of those requirements change and you have to make a change, you're going to add debt. Almost guaranteed. Unless you spend a lot of time kind of like, okay, everyone stop. We're not going to move forward. We got to figure out where the requirements and the capabilities differ, refactor the code, and move forward. I love refactoring code. Most people I have worked with despise doing that. Either because they're very precious about their baby, their code, or because it's a pain for a lot of people. I
Right.
always want to re-optimize everything. A lot of people optimize for speed. I optimize for developer productivity, which is why I'm in a developer productivity role now and have been for like half my career in one way, shape, or form. Because that's where the companies spend most of their money, to be honest. And more to the point, I'm lazy and I don't like doing things that could be done with less of my time. Time is my currency above and beyond everything else.
So you kind of go in and you see, this system is built on a mountain of technical debt. Like, there's no point in adding more stuff until we flatten that mountain of technical debt.
Yeah.
And you love doing that kind of stuff.
I do. I really enjoy it. I worked on a product once that was originally an MP3 player, back in like the Napster days, and then the company I ended up working for like bought the rights to that and contracted with the guys who wrote it to have them add video capabilities because it was going to be a video player. And eventually was. When I came into the job, they had moved on and we had another person who like actually worked at the company who was then trying to deal like with the capability with adding the actual functionality that the company provided, the video security and whatnot, into this application. And it was difficult to work with. So after I'd been there for 6 months or a year, I talked with my lead and I said, I really want to rewrite this and like separate the UI from the back end, among other things, because it would just hang and crash all the time because there was no division there. So I did that, and that rewrite that I did actually ended up becoming the core of. We ported it over to different operating systems. We ended up making it a plugin for web pages. Like the refactoring actually ended up being very, very beneficial there. But I did it because I hated working on the code.
Yeah. Yeah, it's you bring up a good point about one of the reasons why you might want to actually work on, paying down that technical debt, is that it makes it more portable, because when you first write an application, you may be writing it for a specific platform or a specific operating system, but if it gets popular or it gets used, or you might want to port it somewhere else, and if you have it like you just did it the quickest, most efficient way possible to get it to work in one way on one platform, you then create this mountain of debt that you have to work off to make it portable enough to actually go, to be built elsewhere. And so, I can see how that would be a great reason to pay down. Now, I'm curious, just to put this in a less abstract and more example kind of way. You said you were working on an audio player, essentially an MP3 player. Now, what was like one decision that was made when that was first written, where you were like, I mean, you may not have been there when it happened, but when you were looking at the code, you're like, ugh, this was totally written in a way to where it accrued a lot of debt, but it was a lot faster than the non-debt accruing way. Like, what's like a specific thing that was done that you could see?
I think the specific thing is, like I mentioned, that it was an MP3 player before I ever saw it. It had already been converted over to being a video player, but that was where that division of like the UI and the back end was not clear. When you're doing an MP3 player, that's not as big of a deal because you're not doing a lot of visualizations,
right?
Unless you have like a visualization engine. Right. The entire purpose of a video player is to have video playing. And so anytime that would suffer because we were computing something on the back end was a problem. And it wasn't decoupled. And it was clear that there was a decision made like, okay, we have this existing engine, this MP3 player that does a lot of what we want. And if we just add video capability to that, we'll go from nothing to something really fast. And like for prototyping, I think that kind of thing is great. After prototyping, you almost always want to refactor.
Yeah.
And that's where you most often find that pull between product management, and developers. Your developers like, okay, we can add that feature that you want, but it's going to take longer to do that than it would if we had refactored. Well, will it take longer to refactor and then do it? Well, yes. But then the next time they're like, okay, but just do that. Just do that first feature, and then that
Right.
debt keeps accruing, and it becomes longer and longer until eventually it's so painful to make any changes to the code that it's you end up with the big ball of mud pattern, or what's that, spaghetti code,
Spaghetti
all
code,
those kind of
right?
things. I remember in particular in this video player, there was a function that I had to scroll for over a minute to get from the top to the bottom.
Oh.
If I unless I was just scrolling as fast as humanly possible.
Oh, that
But
hurts.
if I would just like tap the down arrow to like move the cursor, it would have taken at least a minute. So that was
Wow.
one of the first things I did, was just like, okay, can we just break this stupid thing up?
Right.
And then I almost always refactor into object-oriented patterns and classes because it's the way my brain thinks. But that's not the only way to do it. But I used that as a way of like, okay, we're going to encapsulate, because it was just the logic and the display were just so intermingled that it was impossible to make a change and not cause some problem somewhere.
Right.
Because the complexity of your code goes up really badly as you accrue debt as well. And you want simple so that you can test it and have it be predictable.
Yeah, I feel like there's, like there's many forms of the joke of like someone looking through a big code base and seeing, some comment somewhere that says like, I have no idea what this function does, but do not change it because the whole thing will break and no one can explain why. And that's like, going to someone's house that has just been hoarding newspapers for, years, and you have to dig through the newspapers to find, I don't know, the refrigerator or something because it's just under a pile of debt. It's like, oh no, don't move the newspapers, otherwise, like the house will fall in or something. And
I have literally written that comment in the code before. Like, I don't know why, but if you change, this shouldn't need to be a 1, it should be a 0, but for some reason, if you change this, everything breaks.
yeah.
We don't know why.
So, as an example for me, my most recent project that I'm working on is a single-page web application. All it is for years, I've wanted the ability, kind of cross-platform, like no matter what application I've written. I mean, I've done some compiled like desktop programming, but most of my programming has been on the web, but not everything. And one thing I've always wanted is just a simple on-screen piano that I can play by 3 different ways, either using a keyboard, if you're at a desktop and you have a keyboard, mapping like the Z to C and blah, 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 or just using a mouse by clicking on an on-screen keyboard, or even more coolly, if you're a musician and you have a MIDI keyboard, also, taking input from that and just using like simple oscillators to play like sine waves. Just if I have an idea and I'm at any device and I have any kind of input available, I want to be able to just tap out a couple notes or a chord just so I can play around with an idea. It's not that no one else has ever done that before. I'm actually looking at an example right now, but I'd never done it. And also, I'd never done anything in Vue.js, which is yet another JavaScript framework. The main one I think that people would be familiar with that uses it, and where I've actually really looked into it for the first time, is Wordle. And it is perfect for making like a single page interactive web application. Now, Vue.js is forcing me, as I'm learning it, to break things into components, which is, essentially their component model is not that far off from object oriented, which is, you should have essentially like a class for each kind of unit of your application. For example, you can have like a unit for the keyboard itself, but that keyboard could have subclasses for like each key, for example, and like or each octave of a keyboard. You say, give me a keyboard with 1 octave. No, give me with 3 octaves. Give me one with notes that are already in a specific scale. No, just give me a normal piano with the C sharp, D, that kind of stuff. And believe me, Matt, it is taking every fiber in my body to not just write one big ol' app.js file that just has all of the stuff in one, because anytime I try to break it up into the subcomponents, then you have to deal with how do the components talk to each other. And how do you send messages and properties and methods and, returns from one to the other, which, is its own Vue.js thing, which is kind of like Angular, which I've used, which is probably like React, which I've never actually used, which is surprising probably because that's like the most popular one, but I never got into it. But I know that if I don't write it in the Vue.js way, I am creating technical debt, because if I want to go back and try to change anything about this, like making it more modular, like, I want it to be able to give me scales as opposed to just a regular piano. Well, if I don't break those into components, it's only going to be that much harder to go back and fix it. And so I'm having this fight in my head right now where I'm like, I know I can just write this in one big file with all the methods and everything, but I know that's not the right way to do it. And so I'm having my own technical debt mountain conflict right now.
And you're early enough in that project where it actually probably makes sense to just shove everything into one so that you can get that initial feedback, so you can kind of see it, the prototype. And like that, there are valid reasons to introduce technical debt, and that is one.
Okay.
Is like, because I have the opposite problem. I will continue to, and I do this with writing, like I'm trying to write a book right now too, and like as I keep teasing it apart, I'm like, okay, well, what about that, what about that, what about that, and like I keep going too far down to the point where I've written no words. I have a lot of notes about what I want to do, which is basically my design, but I have nothing whatsoever. I have not written a single word that would be in the book. I haven't even named the characters yet. Like, I know what they are like. I know what they're going to do. I know how they interact. I know what the problem is. All those things. But I will never start if I don't just start. And that's where you run into the problem with like code, is if you keep like, okay, yeah, I need to dissolve this, but then you get wrapped up in all of the like the infrastructure and the meta of the non-interesting part of the problem. You won't write it because you'll lose interest. So like you got to find that balance between getting something in there that you're gonna have to throw some of it away. Yeah. And that's okay. Right. Like, but you have to plan then to like, okay, when you introduce technical debt, you should introduce it intentionally and say, okay, I know I'm introducing this, and these are the consequences of me introducing this, and then like have a plan to get rid of it. Right. And the best projects I've worked on in my career have all, and that was really like my job as lead architect, was to be like, okay, we can make this concession, but here's the consequences, executive team. Are you okay with that? Because if we're going to do this, we want to do that. And like on a small scale project, you are all of those people. You're the executive team and the architect and the coders.
Yeah. Yeah, I mean, that's usually how it is. And so I almost always just go with I'm just going to make a big mountain of technical debt, because most likely I'm going to do this and then I'm probably not going to really touch it. But I just know that it's like a negative feedback cycle of like, I always let myself off. And so that's just kind of where my head goes no matter what project I'm working on, whether it's my own or at work or something. So I'm trying, especially because something like Vue.js or any framework is like, no. Here's a tutorial. Here's like a create Vue.js app. See how everything is broken up into components. You want to do this. This is the way to do it. I know you could just make functions.php like I've done since, I was a teenager. But, if you ever want to get out of that mindset, it's so much easier to start at the beginning. Like you said, most people don't get to start projects from the start. You have to join a startup or create your own company to really have a good chance of doing that. Normally, you're jumping into a company that already exists. They already have code. They already have infrastructure. You have to navigate it, and refactoring it is probably the first thing you're going to have to do, just because, especially depending on how old the company is. But so, that's where I'm at with that right now.
I think a good middle ground on those kind of things is to identify where you think there's the most, either the most interesting problem and encapsulate it by itself in its own component, class, whatever, or the place that is going to change, right? Like, all right, I'm definitely like you have 3 input methods that you want to do, but let's say you're like, okay, I'm just gonna code up the mouse part. Then you like make the interface class and the subclass that is like mouse handling or whatever, and then shove everything else in one place. And like just having any separation at the beginning makes it easier to start doing that more, but it doesn't bog you down in the details.
Right. Yes, that is a good idea. Something is better than nothing, and that is what I'm trying to do. I'm trying to. I'm both going too segmented, where I'm like, creating a class for every subatomic particle I can think of, and then I'm like, whoa. I don't even have the first component talking to the second one. Let's back it up and make it a little more spaghetti until I got that, and then. Like you said, find the areas where I know I'm going to want to augment it or change it in the future, and have a plan and a structure, like a to-do, like, hey, this needs to be refactored into a class so that I can make these changes later. But for now, one octave, one type of sound. I haven't even touched on like using the like pitch wheel or the mod wheel, which is going to be fun, but not something, the first one out the gate. But I appreciate that. That's helpful. So tech debt, most likely it's inevitable in any project. Refactoring is good. Don't fear adding technical debt, but like you said, have a plan. And if you're doing it for other people, hey, here's the pros and cons of going this way. If we go this way, we may not be able to do this other thing easily later. And so consider that before you make a decision.
Exactly.
Yeah.
And you can always just throw away your code and start over. And
can you though? I don't know. It's so precious.
That's basically declaring bankruptcy to continue the debt metaphor. It's like, all right, I'm getting rid of all my debt. And look, now I got new debt. Yay.
Yeah. I was gonna try to like put this in terms of like financial debt. You're basically like, I don't have the money, i.e. the time, to build this the correct way. So I'm going to take some money from the bank so that I can easily get my house now, instead of like, I don't know, working some side job for 20 years to build up the money to pay for it outright, i.e. doing it the correct OOP or component-based way. Instead, I'm just going to write the spaghetti code now and take the money from the bank, and I'll pay it back later. But will you? And how long will it take? And how terrible will your code base be by the time you finally pay the money back? And how much interest will have accrued?
Exactly. How much? I think the house analogy is great. Like taking out a loan is an excellent analogy of that. Like, yes, okay, now I can own this, but now I'm paying more money because I'm paying that interest every month. Yeah, I'm paying my principal also, but I'm also paying that interest. And that is basically, I mean, like that analogy works very well for technical debt.
Yeah.
I think this is a subject that we could probably come back to multiple times and dig into like specific examples over time. But I think this is a pretty good overview of it.
I agree. I think, don't fear it. It's natural, but plan to get rid of it as soon as you can, I guess.
Yep.
All right.
Pay down your debt.
Pay down your debt. Yeah. Try not to take debt if you can, and if you do, pay it down. All right. Well, that's our show. Thanks for listening to Hacking the Grepson. You can find more episodes at hackingthegrepson.com. We are on Twitter, technically, although I access Twitter through third-party clients, which over the past few days have been rejected by the bird site. So I'm not sure how much longer I want to interact with it while that is a thing. So I'll keep posting our new episodes on Mastodon. I'll put some links in the show notes about where you can see those announcements. Otherwise, just add us to your feed and you'll get new episodes when they come out. Until then, we now return you to your regularly scheduled lives, already in progress.